We're going to look at solving one variable equations just using adding and subtracting. Now when we're solving these equations, what we're doing is looking for a missing value, that value being represented by a letter, usually an x. So here we have a missing x in these three cases, and we're going to learn how to find out what that value is using some algebra. There's two real rules to doing this. The first rule is that we want to isolate that x value on one side of the equal sign. To do that, we need to move all the numbers over the equal sign using opposite operations. So in the case of today, plus becomes minus, minus becomes plus when we move those over to the other side of the equal sign. So we have three examples here to take a look at to practice that. We'll take a look at our first one. X plus 5 equals 11. So we need to isolate the x, and that means we have to move this plus 5 to the other side. To move that plus 5 to the other side, what we do is we copy everything down that we're not moving. So the x equals 11, and when we move that plus 5 over, the opposite operation of plus is minus. So it's 11 minus 5. X equals 11 minus 5. Well, 11 minus 5 is 6. X equals 6 is our result. We can check this to see if we're right by taking this 6 and putting it in here for x. If we take 6 plus 5, well, that equals 11, which is what it's supposed to equal. We got the correct answer. For the next question, we have a subtraction, but done very, very similar. X needs to get isolated, so we got to move the minus 3. To move the minus 3 over, we write everything out that we're not moving. X equals 7. And when we move the minus 3 to the other side, the opposite of subtraction is addition. So minus 3 becomes plus 3. X equals 7 plus 3. 7 plus 3 is 10. And that's our result. And again, we can quickly check that. 10 minus 3, well, that is 7. So that is a correct answer there. In our last case, we have a slightly different type of problem. The x is now after the number, and it has two hiccups that you'll find. One is there's no sign here with the 9, and the second is that the x is a negative x or a minus x. To deal with this, there's a couple things we got to look at. First off, we need to get the x by itself, so that means we have to move the 9. So when we move the 9 over, you think, well, we're subtracting, but we're not subtracting 9. We're subtracting x. The 9 is actually, because there's no sign in front of it, it's actually like a plus 9. So we pretend that's plus 9 minus x. So that means we have minus x equals minus 4. And when we move the 9 over, it becomes minus 9. So negative 4 minus 9. So negative x, notice the negative state as well. The negative doesn't disappear. It's still negative x. Negative 4 minus 9, that gets you negative 13. So negative x equals negative 13. Now that's not the final answer. That's negative x there. We don't want to know what negative x is. We want to know what x is. So how do we get x? Well, we went from negative to positive here. We made it the opposite operation, so we went from negative to positive. So here, we'll do the same, and we'll change that to its opposite operation. We'll change that to a positive 13. So in this case, x is positive 13.